Okay, that should be recording.
Awesome. Slack message me if anything goes wrong. I will put my laptop in the car and try to troubleshoot from there. Have fun programming, everybody.
Crazy. Oh my gosh, this is what the? This mouse stuck? No, it's bad. Yeah, you're right. Oh my gosh. I'm failing really badly. To be fair, this is a really rough angle to do this from. Okay.
Raise your hand if you think Cedric should be better.
Crazy. Lock in for real. Okay. So, starting from this is the wrong slide, chat.
This is the wrong side.
This is the wrong side to start on.
Okay.
So we had to do some reorganization of our content, given the fact that we blitzed through yesterday.
Good job, guys.
Good job, everyone. So we're gonna be starting projects today.
You made our lives a lot harder.
Yeah. So we'll first start with some review with what we did yesterday.
So, first things first, we're gonna do like this quiz style. So whoever slaps the table, I think.
Sure.
Let's do
Sure.
that. Whoever slaps the table first gets to answer the question. Okay. Okay, guys, everyone lock in. Your hand over the table.
Don't hit too hard though.
Yeah, we'll just be watching. Okay.
Yeah.
Okay. Hey. Did I ask
Not
you a
yet.
question yet?
Not yet.
We're gonna take away the table if you guys can't listen. Okay, guys, you ready? Hand over the table. First question. What is an object? Keegan first.
It's a thing in programming that represents a real world idea of a system of parts or something.
You're so right. Okay, guys, for all the people who just joined, we're doing Quiz Bowl review.
Quiz bowl.
I don't know. Anyways, you go, Cedric. Ask a question.
So we organize our code in two main folders. What are these two big folders called? It's okay. Yes. Can you give an example of each?
So this one you could say flywheel for that, and for commands you could call the flywheel subsystem.
Yeah.
Okay.
My turn. Okay, this one, it's not up here anymore, so it's gonna be harder. What are the 4 classes that comprise a subsystem?
You're free to answer as well if you have the answer.
Slap the table. Okay. What are the 4 classes? There's 3 that are always there, 1 that is sometimes there, that make up a subsystem. We learned about it with Advantage Kit and Advantage Scope. Joshua.
Initialize, execute, add command.
That is one thing, but what I'm thinking of is something else.
Yes.
What are the 4 of those? The 4 types. Slap the table if you know. If you know, that's not the table.
Oh yeah. Well, give us 3 of them then.
Okay. So there's sim.
Mm-hmm.
There's IO.
Mm-hmm.
There's
You got it. 2 more. There's one. Think about the robot and what the robot has to do for the other 2.
If we're not running sim, what do we use instead?
I don't know how to say the normal one. You just Java.
What does it interact with?
Real.
Where's our code interact with? In the real world.
Hardware.
Hardware. And then the last one is the biggest or most generic one.
So
Does anyone have it?
Yes.
Software?
Close. Starts in the S. Starts in the S.
Anyone else?
SU.
Superware.
Yeah, just a
Yes,
subsystem.
subsystem. Good job, Ryan. Good job, everyone. That was a hard one. Okay, we'll do one more. Cedric, you got this.
Oh boy. We talked about
Keegan
this
is
pad
loud, guys.
yesterday.
We like Keegan.
I don't know if you guys remember this. What is the actually? Okay. What part on the robot gives us its orientation?
The gyro.
Good job, guys.
Good job.
Okay, you guys remember what we did?
Amazing.
Good job. You were listening. That's good. Okay.
Okay.
So let's continue. It's on this one.
It's on that one. It's on the backwards one. That one's
It closed out of this one.
it's extended.
Ah.
That's why I had to look over. That's why it was really weird.
Cedric, you should come over here.
I didn't have that.
What are you doing?
Okay, buddy.
You're flashing it.
Wait, it's not
That's all
working.
good, it's
right?
good, it's good.
Review. Okay, never mind. Go.
Crazy. Okay.
Okay, so now we're gonna talk about our project. So we're gonna use this.
Oh,
we're
we're
gonna
using
use
Melman.
Melman, not this guy.
So then we realized, you remember that swerve? It's kind of a pain to code, and it's kind of really complicated if you've never done it before. So instead, we'll be using
The suitcase
this
spot
over here.
over
A collar.
here. If you guys can't see it, then you can stand up, whatever.
Yes. Please come closer.
Please come closer. I will bring.
Everyone, let's come around and
Where are
gather
you?
around the suitcase spot.
So as you can see,
Apparently the only people on the call are.
Can be a suitcase if you remove 4 balls.
So I yes, do have that, just so we have that for the recording.
Okay. So as you can see, this is the suitcase spot. We called it this. This was maybe 2012. 13?
13, I think, because that's the first year we went to China. That's what
Okay. Yeah, we made it so it could transport to China easily in your suitcase. Hence.
folds.
It folds.
Mhm.
When the sides aren't folded.
Yeah. So, what are some main things you guys see on here? You guys should just shout it out.
Como Rio.
Yes.
Wheel.
Yes. Yes.
Battery.
Mhm. Motor controllers. Yes. Wire, radio.
Battery.
Battery. Yes. Okay.
Gears.
Metal.
Exactly.
Main
You guys got it. Okay. Did anyone say what this is?
Motherboard.
No, not there.
Power distribution panel or power distribution hub?
Yes.
First one, PDP.
I forgot
So,
what
does
the
anyone
first
know
one
what that is? Raise your hand. Brian.
It's how you get power distributed from a hub. It's where we connect all the power cords, and it's where we put all the breakers so that we don't burn out the things we attach to the power.
Yeah, you kind of want to be connected and distribute power hence the name. This is our main breaker that turns it on and off. I'm sure you guys have turned it on and off a lot before. But do we know what this is over here? Giving you a hint, it is a sensor.
What part are you pointing at?
The under. Wait, what we talked
Yeah,
about
yep.
yesterday?
Yep, just I would tap the top of the gear.
This right here.
This is kind of a hard question to answer if you haven't done this before.
Potentiometer.
Yeah.
Does everyone know what potentiometer is?
Yeah.
No?
Then
Okay.
it makes coding super hard because it makes everything off always.
Cedric, what is a potentiometer?
It tracks the orientation.
Exactly. So,
Along 360 or a certain number of turns usually. Right?
Other
Yeah,
things.
so the potentiometer itself just measures position, and it's up to us as programmers to determine what that position actually is. So in this case here, we have our potentiometer attached to a gear. We can use that potentiometer to tell us the angle that the gear is facing. Other times we've used potentiometers to connect to something that moves linearly. And so-
Climbers.
Yep, like our climbers on Odie last year. And so we can use the potentiometer position to give us like a linear amount of displacement on mechanism.
I'm gonna try to swap audio so that you guys can hear better.
Super important thing about
So-
potentiometers. Actually, let me pose this question. Something that's really similar to a potentiometer is an encoder. Does everyone know what an encoder does? Can anyone tell me what the difference is? Look for something other than that.
Oh, frick.
How's that work? I'm
Okay.
pretty sure
Focus
encoders
on
don't and use a slightly different system of measuring it. I'm not entirely sure of the difference.
They do use different systems of measuring the angle. Not all potentiometers have a limited range of motion. The ones that we typically use do because they're easier to program. With potentiometers that have a limited range of motion don't have any sort of dead zone in there. But if you get a potentiometer that is continuous rotation, there's typically a dead zone where you can't actively tell what the position is. But that is not the difference I was thinking of. Say we want to use some sort of sensor to tell us what the angle of that gear is. And then let's say we turn the robot on, we move that gear around a little bit, and our sensor's telling us what direction it's going. Shut the robot off. Turn it back on. A potentiometer and an encoder will give us two different readings. And anyone guess what those readings are?
Would the encoder go back to zero and the potentiometer would read the same thing?
That's 100% correct. An encoder measures a relative position from wherever it starts, and a potentiometer measures the absolute position. Yeah, we can set what that zero reference point is.
Usually
It depends on the application. So for a gear like this, we might set it as forward is our 0 point. On our climbers, we have all the way retracted being our 0 point. So 0 can mean something different than that.
Anyone have any questions about any of the hardware on here? This is what we're going to be using for our main programming project. Main things we'll be working on is obviously programming the drive base, so we'll be able to use that. We'll be programming the potentiometer, which you just talked about, the gyro. We'll also be doing simulation stuff. We'll also be doing some shuffleboard and dashboard stuff, and at time we'll do some basic autonomous. If you guys don't know what that means, we'll go over it, so don't worry. But does anyone have any questions so far? Perfect. Okay, so I think we're good to go back to our seats and we can start coding.
We'll take this. Okay.
This was like the most generic version of it ever. It's kind of incredible. I have a generic version.
Okay.
What's going on here?
We'll swap on back
Stop again.
for sure.
Could we get Black Sword from there? What it is.
Okay. So I'll be back.
You want to start it?
Probably not.
Or how
So
do
yeah,
you
we
do
just
it?
went.
You have live share and stuff? With stuff like that.
Live share. We can live share from here.
I don't know. So
Do you want content to go get SSH?
yes.
Yes, she is. Because I. I'm so sorry. We've been muted
The 525 people.
for a while. Oops. So I don't know how long we've been muted. Sorry. But basically what we've done is we've installed this nifty extension called LiveShare, which basically allows us to create a session on VS Code and allows people who have computers like Chromebooks to join and code as well. So all you need to do is just go to the extensions, type in LiveShare, install the first link, and then on this little menu, you'll be able to, it'll look like this, and you'll be able to click share, and then there'll be a little pop-up. You can copy again, just make sure you have the link, and just send that to whoever you want, and then they can join your VS Code session.
Sign in. Continue as I guess we should
Yeah, is one of you
go.
starting live share session?
Yeah. It's still loading.
Still loading?
Yeah, it's loading.
Yeah, if the site
I'm waiting for post approval. Hurry up.
Why do I have C bad buttons? I've never coded in C the name
But go. So, wait, do I have my own? I did the thing. Did I do the thing? I did the thing.
Are you on his thing?
I think I'm on the thing.
You can see if you change it.
So wait, do we
Oh,
both have our own?
No, that
Okay,
I think that you
so-
change will directly be changed on the. But why can't you just auto sign? Okay.
I'm gonna delete all the codes.
That would be great. That would also mess up just as much as it does.
Fair enough, I guess.
Are you on the same level? You can follow each other, by the way.
So, that's crazy. Wait, do you follow me? Or do I just, if I don't do anything?
Okay, so for a little bit of background, most of you have probably figured this out at this point. But what LiveShare will do is it allows who's ever on the Chromebook, and actually this works for any computer, not just a Chromebook, but they will connect to the LiveShare session, and at that point, who's ever in that session has access to all of the code on the computer of who's ever hosting the session. You can have multiple people connect, so if we say, Keegan and Sakeeth and Ryan all want to program something together, one of them can host and the other two can connect. And so all three people can be working on the same code at the same time. Sorry, there's a fly in front of me. So this is how we're gonna have people on Chromebooks program this year. So find a buddy with a laptop and you can work on code together. That's the goal.
Oh, why are you following me?
Like now he's working on some project, still don't worry about and then having
No, I'm ready.
I'm just trying to move it
Oh,
out.
you're kidding me. You know what? I'm gonna move Keegan now.
I'll take over.
Okay, so do you want to go over the forms?
I feel like it should be fine to just start.
Okay.
Because
So who's ready to start writing some code?
Yeah.
Yeah.
young guys are build constants.
Okay. So if you guys have some red stuff, that's okay. We'll figure it out. So just ignore it for now.
Just build constants.
Um.
You have something that you want?
No, keep going. I'm gonna see if I can figure out where to.
Okay. So
disable
the first
that.
thing we're gonna do. Okay, guys. So let's listen up. For our 4 classes that we mentioned earlier of Advantage Kit, our IO, our SIM, our hardware, and our logic, our subsystem, which one do you think we should start with first? Let's throw out your best guess.
What do you think's the easiest to start with?
Yeah. And after we saw yesterday. There's no right or wrong answer. It's just your guess.
Constants.
That's not one of the 4.
What were you talking?
Remember our 4 Advantage Kit classes? Our SIM, our IO, hardware, and subsystems. I heard IO. That is a pretty there. Okay, it really depends on what you're making, but in general, IO is really easy. Do we know why IO would be really easy?
So IO is actually needed to be created before you make either IO hardware or IO sim, because it is the base that you build everything off of. So making IO is generally also easier because you don't have to program all the functionality of your subsystem or any of your other files. You just have to pretty much list out what you want to log and what you probably will do in your subsystems with your hardware. So we'll probably start with IO once.
I have one thing I want to try for everyone super quick. Okay, so in your repository, kind of towards the bottom, you should see this file called build.gradle. And in this file, Cedric, can you scroll up to the top?
Mm-hmm.
There's going to be a line here. It's line 4 in this version. It's talking about this thing called G version. We don't want to install that, so go ahead and comment this line out. But put 2 slashes at the beginning of the line. All right, did everyone find that?
Which one?
The one that says G version. And then go ahead and scroll down a ways. It's like line 200 or so. Right here. Oh, I lied. Line 140-ish. Okay. On line 135, there's this thing that says create version file.
Oh, that's already commented out.
Create version file is commented out. We want to comment out the stuff below that. So you'll need to comment out lines 136 through 144. Okay. Everyone got that part done? All right. The last thing that we'll need to do is tell our code not to depend on any of that stuff that we just commented out. So go to robot.java and then go ahead and scroll down a little bit. Okay. Lines 42 through 57. We're going to comment out all of that code.
A quick shorthand is control, and then your backslash or your slash your question mark. I am so good at English.
How do I undo?
Is he actually driving? Yeah, he's definitely doing that. Oh, yeah. I just want to make sure. Brother, let me have access. Look, I muted it.
Okay. So has everyone done that so far? Make sure to save your files, by the way, or else you'll lose all your progress. You can tell how do you save your file? You can either just the easiest way is just to tap Control S. That'll save your file. You can tell if your file is unsaved because at the top of your file there'll be this little circle. So once you save your file, that circle should go away. Yes, Joshua.
I did Control S and it didn't do anything.
Let's go check that out.
Command S. You're on Mac.
Oh, you're on Mac?
Command S.
You know how to save a file, Josh. Okay. So we'll probably get started with coding our first class once we maybe wrap up that. Okay. So generally what we like to do is we'd like to create a separate folder for all of our subsystems that we call subsystems. So the first thing you'll do is on this Java FRC robot tab, you'll right click and you'll click new folder and you'll just type subsystems.
Or you can click the plus file button up and then.
That works too. You have to be in the right scope though.
That's fair. Sorry.
All good. And within here, we'll probably create our IO class or interface. So does anyone want to take a guess at what we'll probably call the IO interface for our drive subsystem? Ryan.
Drive IO.
Yes. Drive IO. I don't think there's a command. Is there a specific command to create an interface? I don't think there is. Okay. I'm not crazy. So just create a new file and call it drive io.java because it's a Java file. And this one will not be a class. This will instead be an interface. Oh my gosh. Okay. So has everyone created their interface file? Put a thumbs up once you've created your interface file. Joshua, are you good?
Yeah.
With the auto log, drive IO inputs, and then you'll apply the auto log annotation. If you mess it up, I'll tell you.
I'll get it.
Nice.
I have that. That's embarrassing.
Okay. Is everyone at this point?
How do we get rid of this? You right click on it and then you click delete. Yeah, but like. A magical thing.
Yep.
The issue is that your subsystems folder is because that package needs to do the exact same thing. So you need to just rename your folder to be
Oh, okay, it's not.
Yep.
Raise your hand if you have any problems. Yeah.
Are you having any comments, John?
It goes away.
Okay. So it'll probably continue going on. So I'm going to type some things that are going to not make a lot of sense, and then we'll explain them in a bit. So first we type at autolog, and then public static void drive IO inputs.
Cedric, can you zoom in? Just hold up.
I'll close this for now. Does that look really bad?
No camel case?
Nope. No camel case. Oops. This is a public static class, not void. It's not a function, it's a class.
Why is
My apologies.
it not a camel case?
Because it's a class.
So, camel case we use for variable names. This is called Pascal case, or it's camel case, but the first letter is capitalized. We use that for class names, interface names, object names, things like that.
Yeah, it doesn't like the name drive, IO inputs. What your daily races after that? Here you go. Whiny.
Cool.
So basically what this does is this creates our inputs class. To have everyone's attention. So basically what this does is it creates our inputs class, which is where we declare all of our variables that we want to be logging throughout the match. So can anyone think of what we want to log on our drive subsystem?
Point scored.
Point scored?
Think
Would that
of
be, think of stuff that we can see from the robot's point of view.
the thing like our behaviors and attributes that we were talking about
Yep.
yesterday. We want to log the attributes.
Speed? What speed?
Like specific wheel speed.
Like left wheel speed, right wheel speed?
Wait, so it's got 2 left wheels and 2 right wheels.
Yeah, so what we do with that.
Back left, front left, right left, left left.
Public. Oh, public. Public. So is it might be static?
Right back left.
Static.
I'm right.
And then what
Just do one for
what data type do you think our wheel speed would be? One of our wheel speeds would be. Yes.
Double.
I agree. Double. And Ryan, do you want to give us a name for one of our wheel speeds?
Front. Wait. Names of wheels. Would front left work? Or
Front
would
left?
that be the-
We'd want to add in kind of the information that is talking about the wheel speed. Because front left can be a bit ambiguous.
Front left wheel speed.
Perfect.
Perfect. And we'll shorten front left to FL because
anyone
it's a
know-
lot of typing, yeah?
Sorry. Does anyone know what case typing we use in Java? Yes. And
That's
what does
weird.
camel
Yeah.
case involve?
Does that work?
Ethan, explain camel case to us.
Okay, so camel case, it starts, the first word is, the first letter of the first word is under,
Lowercase. Yep.
And then all the other, subsequent words are capitalized.
Exactly.
Or sorry, don't make it static. Actually, don't even worry about those, but don't do it.
How are we going to initialize it to evaluate it?
We're not running vectors. We're running scalars. It's
Yeah,
static.
It will. If you have static there, that means if the robot ever gets 2 drive bases, all sorts of other.
Yeah, if
Okay.
we won't have 2 drive bases, but if that's 2 drive bases, then they'll both share the same front left wheel speed, even if we command them at different wheel speeds.
I have a question for you all. So some of us here might have not programmed in Java before. So does anyone notice anything special about the end of this line right here, line 10? Exactly. So in Java, semicolons are very important.
Without them, everything falls apart.
Yeah, so essentially they end each line. But I have a question for you guys. Why does this line not have a semicolon? Yes, exactly. So that's our class declaration. So we do not need to put a semicolon there. Yes, there are curly brackets, but there's no semicolon. That'll come with experience, and we'll learn more about that later on. But yeah.
So
Does anyone have any questions so far?
You just name the rest
Yes, Keegan.
Why is this class static?
So the class is static because most of the time, if you want to use something inside a class, you need to have an instance of that class in order to actually use it. So like if we put a method inside our spaghetti class, we would have to have a plate of spaghetti in order to use that method, right? By marking something as static, that's saying you don't have to have an instance. You don't have to have an actual plate of spaghetti. You can call this function directly from the recipe. So this is saying that you don't have to have a drive.io object in order to access drive.io inputs. You can access drive.io inputs on its own through the drive.io interface.
So after this, we have our function here, right? It's initialized to 0. So that makes sense because we're in the IO class. It's not really being used. We're just creating it to be used later on. Okay, so after this,
So the line that we're on right now is an example of one input that our robot program might have at any given point in time. We can know every time we go through our code, this is what my front left wheel speed is. What other sorts of inputs do we think we have?
yeah.
Front right, back left, back right.
Yes.
So do you think we should change? So this public right here, if you guys aren't familiar, this is called an access statement. Right? Yeah. So essentially that's kind of like describing where it can be used and stuff, and it's public, so it means it can be used by other classes. So other classes can access it and that kind of thing. So we can do fr wheel speed equals 0. We have a public double. We can also copy and paste it. That might be easier. Backlit wheel speed.
Don't forget that the back right wheel speed needs to be a Boolean.
Oh, wait, are
If
you
were
real?
confused by that statement, that's good, because it was complete nonsense. I was trying to see if anyone was going to catch me on that.
I was like,
Okay,
Yes.
Wheel speed is not a Boolean. Your wheel speed is not true or
I don't
false.
think.
Yeah,
Real power would be a Boolean. Like, if there's
Yeah,
voltage.
we will
But we
spin.
don't. Yeah, we'll spin.
Yeah, you work on wheel drive.
Angle
What's that?
is angle.
Is and can be. Is this an angle? Probably. Maybe. I don't know what that means.
Is there an undo button?
Control Z.
Yeah, fair point.
Is angle Boolean?
okay. How's everyone doing with this so far? Does anyone have any questions or anything? Are we good to move on, or do we need a little bit more time?
I think we're good.
Okay. So now that we have these variables, we're going to move on to math.
I can think of one more.
Oh, yeah. What is this other input? I forgot about it.
Anyone have any ideas?
It was said earlier.
Yes.
So the potentiometer is actually going to be a part of a different subsystem.
Gyro?
That's also.
Okay.
That'd be a system.
Gyro's not a different subsystem.
There isn't that.
The gyro was only a different subsystem last year because it was needed by multiple subsystems. Typically, the gyro is going to be part of the drive
Yeah.
subsystem.
But yeah.
So yes, yeah. Anyone that said angle earlier when we were trying to list inputs, the angle of the robot is the input that we're looking for.
And what data type would represent that angle?
Double again.
Public
So-
double. What do we want to call this?
Robot
Sorry.
angle or RV angle.
Let's call it robot.
Robot.
So Josh actually said a very valid point. I think he said earlier, why don't we use floats? So the difference between doubles and floats is simply their size. So doubles have allocated double, hence their name, the bits to kind of represent their values. So it allows us to get a lot more precise and allows us to store a lot bigger variety of numbers. Generally, it doesn't come super into play, but we just like to have it. Yeah.
So that will allow for more?
Yes, more precision. Yeah.
So
is the
let's think about it this way, Ryan.
It's just for
number
initializing
in a
it.
computer, you have to store that in the computer's memory, right?
Mm-hmm.
And so typically you reserve an amount of space for each number.
Yeah.
The smallest unit you can work with is 1 byte, which is 8 bits long. And a bit can be toggled on and off, right? So if you think about how a number is represented in binary, you can represent 0 as they're all 8 bytes are 0. You can represent 1 as 7 zeros and a 1, and so on and so forth. You keep counting up in binary like that. So that's how you would represent an integer. Some really smart people figured out a long time ago how to represent numbers that have decimal places inside an amount of space using a designated number of bits. A the exact number technically changes depending on programming language. A float usually uses 32 bits. And exactly what each of those bits means changes depending on what number you're trying to represent. Some really smart people figured out what all that means, and every computer everywhere does it now. You don't have to think about it. So a float has 32 bits. A double has double that. It has 64 bits. And more bits means there's more possible numbers that it can represent.
Okay.
So the triple represents like
A triple's not a thing.
quadruple?
No, there's nothing.
There's nothing past double. There's nothing officially standardized past double. There are some languages that have definitions for more or less precision.
So does Java allow us to store past the double then, or?
Let's see.
How about 100? Maybe 100?
Any number that you could ever possibly want to use in FRC, a double will
Yeah, just in theory. I was wondering how far I could get this conversation off the rails. Sorry.
I have a number of 50.
Okay. So
We're gonna keep going.
We're gonna keep going, yeah.
okay. So about my comments here, these are just for people. You don't have to write that. It's just something so people can continue to look back on. So now that we have these, do we want anything else? Can we think of any more? If not, that's okay. I think we're good. Okay. So now that we have these variables, we can move on to methods. Okay, guys. So now we're going to create some methods that are going to be used in this. Can we think of anything? So these are the attributes, right? These are the things these are the traits. Now we want to do some behaviors and methods. So what are some behaviors we want? Or things we want to do?
What can we tell our drive base to do?
Yes, exactly. Yeah, Brian.
Go forward? Would that even
Think
be
more
helpful?
general than that.
Think even more.
Maybe it's not necessarily go forward.
Drive.
Drive.
So
But what do I need to know in order to know how to drive?
Because
Yeah.
drive would probably be more in the subsystem class itself rather than the I/O. Because the I/O really deals with the nitty gritty of the hardware and how to interact with the hardware.
Interact with hardware.
Power engine. Yes.
I don't know.
that's close. So like we can thinking more about like even like what about the motors?
Power motors.
Yeah, right?
Yep.
Is that what
Yeah. So the we're not going to do set voltage because I don't actually know if these microcontrollers support that. Oh, sweet. All right, yeah, we'll do that then. Yeah. So we have a left side of our robot, we have a right side of our robot. Even though we have two motors on the left side, two motors on the right side, can anyone think of a situation in which we would want the two motors on the left side to be moving at different speeds? The two motors on the left side?
side.
No.
Oh, I was about to draw a FTC and strafing.
We all have mechanisms.
So there is a kind of drive base called mechanism where it is possible that you might want to drive the two wheels at different speeds or even towards each other, which is just kind of weird if you haven't seen them before. For the suitcase robot here, our wheels are not mechanism wheels. We will always want to drive the two wheels on the same side at the same speed in the same direction. So our two left wheels always go in the same speed, same direction. Our two right wheels can be different from the left side, but they need to be the same as each other.
Yes.
So if we want to be able to command our left side to move, we can do that, right? We can say, hey, left side, move at this speed. Or we could also say, hey, right side, move at this speed.
So if I'm hearing you right, the wheels will not be on the same side, won't be going at different speeds.
Right.
Yeah.
Yep.
Okay. Perfect. So we can create, well, talk about this. So now that we have that idea that we want to move two motors or one side, we can create methods that turn this on so we can use it in the subsystem class later on to actually turn and make our robot drive. So to do that, we need to make a method. Does anyone know in Java what method header would be?
So basically the declaration for the method. Does anyone have any ideas for what we would write here?
Public.
Yes.
Yes. And why would it be public?
Because we want to access it from outside.
Exactly.
Yes.
Okay. Now what?
We need a return type.
This one's cheating.
This
You need the word default.
Default. My bad. I forgot. This is a weird class. This is an interface. My bad.
Then we
So-
need void, right? Or some sort of return type.
Yeah, we do need a return type. It would, in fact. Yeah. Okay. So now we have this. We can name it. What do we want to name it?
Power left.
That works. Power left. And we'll have our parentheses. And yeah.
Do we need any parameters?
Does everyone know what a parameter is? Okay, good. Do we need any parameters like Cedric asked?
Speed, or maybe the power,
Power?
whatever you're using to determine wheels.
What does power represent? If I tell you move at 7, what does 7 mean?
Voltage.
Rotations per minute.
This is exactly my point. It can mean any of these things. So let's pick a name that is representative of the unit that we're actually going to be feeding it.
Voltage. We can do voltage.
So let's name our parameter volts.
Mhm.
What is the data type?
Double.
Is it double or is it int?
You can't really give
I mean, make it double, why not?
1.5 volts.
Yeah,
Yeah, you do. Our breaker usually loads with
So,
12.5.
let me ask this, Wyatt. You are really familiar with our batteries, right? How can you tell when a battery's charged?
Oh, like the green light.
Do you know what voltage a good battery is at?
Oh, around 150 something.
Voltage. Not kilowatt hours.
Voltage? Voltage, yes. I don't know.
So like when we look at the robot on the driver's station, a lot of times we'll check to see, how many volts does our battery currently have, so we know if we need to change that out. A lot of times we're looking for something that's at like 12.8 volts, right? So that's to say that voltage is representable by a double.
Yes. Exactly.
We'll use a double for our volts here.
And then we probably won't have anything in the body right now because this is just our I/O class. We will actually define all this in our I/O subsystem, or I/O hardware and I/O sim classes.
It might be a little hard to wrap your head around like why we're doing this, but essentially we're just kind of creating an outline that we can use later on for when we're actually doing logic and stuff like that. That makes sense to everyone? We can kind of close these up. Okay, so we have this for the left. Can anyone think of what else we might need? Yes, exactly. So we can also do something exactly like this, but for the right.
Is everyone here?
Does anyone need any help? Okay. Yeah. So now that we have these methods here, can we think of anything else we might want to have? Consider we have we have these kind of like powered and stuff. What else do we need? Yeah.
I'm sorry, I missed it. What?
Do we need something for gyro?
I think it should be handled by
Yeah.
So the methods that we're creating are typically used to command our hardware to do something.
Mhm.
Whereas the inputs that we've listed in a static class up above is typically used to read an input of some sort. The gyro tells us what angle our robot is currently pointing at, and so that is an input into our program, which means we want the variable for it up in the static class. Can we think of anything that we might want to do to command the gyro? Is there a command we can issue to the gyro? Yes. What can we do?
Oh, it's just left right there.
Keegan, when you say turn the angle, what do you mean by that?
I mean, like, could we give it, like, method to return the angle? That could be the.
So that's what the variable up above will do.
So, if you all are familiar with our robot from last game, we had a button on our driver joystick that would allow us to change, because our robot uses field-centric drive. What happens if our gyro gets off and, for example, when we push forward, the robot goes to the side? What do we have to do?
Reset the gyro.
Is that what you're getting at?
Yes.
Okay.
Now I will say this robot will not have field-centric drive, so
Yes.
forward will always be forward relative to the robot. Zero just lets us, resetting the gyro just lets us change what direction the robot thinks is globally forward. It won't ever drive that direction, but it'll know where it is.
And we might use it for potential.
Yeah, I've thought that more. So yes, we will likely want a method to reset the gyro.
Okay. So what would the first word be here?
Then?
That's not how you spell that. Okay. What are we returning? Trick question. It's void.
Nothing.
Okay.
And what do
And
we call this method?
Reset gyro.
I love it. Do we have any parameters for this function? Yeah. We can call it reset.
We can say no for now. There are some times where we'll want to do things like say, hey robot, the angle that you're at right now, it's not the new zero, it's 30 degrees. I was about to say, I don't know why we'd ever do that, but we actually literally did that with Grasshopper. Grasshopper. Because our 0 point was up against a field element that was at an angle on field. So, but for right now, we can just say, hey, whenever we press this button, we'll go to 0. Yep.
Does anyone have any other methods that they can think of for this interface?
and if not, that's okay.
All right. What's next?
Okay. So now we have 3 remaining classes that we have to make. Let's go over this class first. So we have our 4 variables here. They represent the speed of our 4 wheels on our robot, right? That we can log and keep track of. We also have a variable for our gyro angle that we can keep track of as well. We have 2 methods for powering the right side of our robot and the left side of our robot so that we can turn that on and drive in using the logic subsystem class later on. Then we also have a method for resetting gyro so that we can eliminate error if needed. So now we have the 3 other classes to do left. We have sim, we have logic or the subsystem class, and we have hardware. What do you guys think we should do next? I heard one hardware. Hardware?
Let's do hardware.
Let's do hardware.
Okay. So, does anyone remember, everyone, to make a new class, we're going to right click this. We're going to do new file. We're going to go down.
And then there's a method. There's actually a W-driver.
Yeah. Create a new class command. You can click on this. There's an empty class. And it's going to be called drive. What's it called? What's the,
Drive.io.
is it Victor SPX?
Sure. I think
Drive IO Victor SPX. We'll do that.
Okay. And what does Victor SPX mean for this?
Does anyone have any guesses?
Motor controller.
Yes, that's the motor controller we have on the suitcase bottom. So we'll generally name it the motor controller or whatever hardware that we're actually using. If we have multiple pieces of hardware in that subsystem, we'll generally just call it hardware itself.
Okay. Does everyone have this, or anyone need help?
So it's gonna be, you can do it the easy way, you can do it that way, and then then you can go down to. You just create it in the. Actually. Hey, Colin. If you guys do it right quickly.
Yes, and then start discussion. Oh, remove the dot type. Remove that dot. That's weird. Can you press escape real quick? Oh, you're trying to create a command. Okay, so can we replicate that and then create a class command? And then so okay, the second one. Java.
So go to your drive aisle.
We got it.
Go back to the first mix. And cover over it. And you're gonna do quick fix. So go over it.
Yep. Yes.
Great.
Amazing.
It just kind of, there's
Yeah, package.
Okay.
All right.
Is everyone good?
What's next?
Sure. Okay. So, what's very nice is after we've created our interface, we can really base all of both our IO hardware and our IO sim class on our interface as like a guide. So if we go back to our IO class, we can see some of the attributes that we want to use in our IO hardware class. So for example, front left wheel speed, front right wheel speed, back left wheel speed, back right wheel speed, and robot angle. So what we're able to do is if we go back, I believe we create, or do we?
So the first thing that we need to do is, because everyone noticed how the first file that we made was called drive.io. The second file that we made was called
you're right.
Victor SPX. That means what we're trying to describe is that this drive.io Victor SPX is a type of drive.io.
Yep.
And so the way that we need to note that in the code is after we have our class name, we put the word implements and then the name of our interface, which is drive.io.
Bye-bye.
Is it
Yes.
like use the interface that we just created?
Is that similar?
Yes.
Similar. Extends is used for classes. Implements is used for interfaces. No, that was a really good question. Yes, they are very similar, but they are used in different contexts.
I don't know if we create variables for that.
You don't need variables here. One thing we did for that was inputs.
You're so right. Okay, so we actually forgot a method in our drive.io Java class or interface. It's crazy. This is actually quite an important method. You don't actually use this unless you're using AdvantageKit, but it is called update inputs. So what it does, we'll have a, I believe, I don't believe so.
Not at this point. When you're actually implementing it, you put that over it.
Gosh. And I believe it's void, and then you'll have, I believe you don't, there's no parameters for this function.
There is.
There is? Is it
It's
IO input?
drive.io inputs.
Drive IO inputs. So you'll have a drive IO inputs. We generally call this just inputs.
So this is something specifically for Advantage Kit and stuff. It will be used so that we can continue the scroll up a bit, Cedric. These variables that we just created, this method will allow us to continuously update those when your is running, so we can do some stuff like after simulation.
That'll make a little more sense what this method does once we actually.
Yep. So, do you want to start with the constructor, or do you want to start with variable declaration?
Do we need a constructor?
Do we need a constructor? What does everyone think? Yes. I heard one yes. Do you think we need a constructor?
No.
No. We have one yes and one no.
Maybe.
Yeah. Go with no. 2 yes, 1 no. Take it, John.
Yeah,
2 yes,
no.
1 maybe, 3 yeses, 2 no's.
Let's go with yes.
Maybe.
This is a class.
No, then.
So,
It's equal. 3 yeses, so 3 no's.
So, yeah.
Constructors are needed when you need to initialize data that is contained within the class.
yes.
Do we have data that we need to initialize inside this class?
Maybe.
Nothing inside.
Perhaps.
Maybe. Maybe is the correct answer, depending on how we want to do it. So the first thing that we're going to do, before we even get into the constructor, is I'm going to start by asking, what does this class need to actually contain? What variables or what attributes, I'll say, are contained inside this hardware implementation? Another way of saying this is, what hardware do we have on our drive base?
Yep. So, what hardware will we need for this subsystem? Yes. Yeah.
Or Victor SPXs.
Let's start with one.
So, do you have any idea how to declare that?
Is it a Victor SPX variable type, or is it not?
A Victor SPX is a class. We'll need a few things before that, though.
So Victor SPX is the type.
Yep.
Before that, we will typically have that access modifier. What access? Cedric, ruin the secret.
My bad.
Private.
It's private. Yeah.
Do you have any idea why it's private?
We don't want it to be changed by other things in the program.
Yeah, that's exactly right. If we have another subsystem, like say we throw on a climbing system on the suitcase, but we're not going to do it. Say we did. We wouldn't want the climber to be able to change our drive inputs.
Could we put the climb system on?
No. Do you have any idea what we put after private? It's okay. Final? Final? We can. So does anyone here know what final does that aren't Saketh? Because he suggested it.
It's fine. The last one. Only one ever.
Kind of. So
That's actually exactly
that's pretty much it, yeah. It just makes it so you're not able to change this variable. So once you set it, it's set forever.
Yeah, it's basically static.
Yep. Well, static is
a little bit different.
different.
So the difference here is if we had made this class static, if we made this variable static, that would mean that all Drive.io Victor SPX instances would have the same motor. Whereas by making it final, that means if we have multiple Drive.io Victor SPXs, they all get their own instance of that motor. Final just means that they can't change what motor that's actually referenced. So final and static are a little bit different. We don't want static in this case because if we did have multiple Drive.io Victor SPXs, we would want them to each have their own references to their own motors.
Okay. So after final, does anyone know what we do after this?
This is what Keegan was talking about earlier.
Yes. That is 100% correct. Victor SPX. And then here comes the variable name. Does anyone have any ideas for what we would want to call our Victor SPX motor? Or one of our 4 Victor SPX motors? X.
X1, W, X, Y,
A.
we generally like to keep our variables to have some sort of meaning in their names, or else we generally don't merge them in. Huh?
Jeff X1, all uppercase.
No.
Okay, so how about we go with FL Motor?
Great idea, whoever that was. So we'll go with FL Motor. So it's very concise. I very much like this name. I wonder who suggested it.
Don't forget your underscore.
Well, yeah. So as Colin just brought up, normally we just call our variable FL Motor, but generally we add an underscore in front of this. Does anyone know why? So what this means is it means that this variable is a member variable. So it means that it's carried through the entirety of the class instead of just being tossed away at a certain point. So
It means if we have multiple methods inside our class, we can use this variable inside any of those methods.
yes,
The underscore isn't something that we have to have, but it's a way for us to know, oh, hey, I'm inside this method and I see a variable that has an underscore. That means it's likely that I've used this somewhere outside of this function as well.
it's just a naming convention that we'd like to adhere to keep our code a bit more organized. So, and does anyone know the process for instantiating this? Yes, equals new. Well, it gives you the answer right there. Victor SPX. And then we currently don't know what the device number is right now, but we'll just put it at 0 for now. Okay. Does anyone have any ideas for what other hardware we might need? No one?
The front right.
I agree. Do you know how we would make that?
Copy paste, but change FL to FR.
Yeah, mine's broken.
Yep, change
Yep.
the-
So FR for real. And we'll change it from 0 to 1 for now. Any other hardware that we might need? The other two? I agree. So we can probably just copy and paste these two down. And we can make back left and back right. Just BL and then BR. And then we can have these be two separate ends as well. Everyone follow so far? Everything makes sense?
Coming up with an annotation in front of the integer with just device number.
You're almost fighting yourself.
Or would
I'm not
turn
gonna-
off, you can.
There is a way to turn it off, but it's in the settings.
Only if you make it. Well, why would you do that?
Okay.
I don't know.
I don't know. You tell me. You're the one who's gonna break it.
So,
What? I didn't break anything. I just had random questions of letters and numbers. Well, sure. Already?
Yeah, that's fine.
it's been an hour and 20 minutes.
How have we not done? How have we not done anything yet?
So super quick here. I think because we've been diligently programming for about almost an hour and a half now. I think we're going to take a quick 10-minute break. We'll reconvene at 7:30.
I think.
All right.
So get a snack, go to the bathroom, hang out.
Hey,
I'll be back.
If you have any questions on what we've done so far, feel free to ask. But we'll keep on trucking at 7:30. Okay. I